You've already seen the most simple type of tuple assignment. On the right-hand side of that assignment, you have the tuple, defined as a group of elements. Assign the tuple to a local variable, and the type of the tuple will be inferred. Optionally, you can specify the type of each field in the tuple, which uses the same syntax as when we create the tuple. With this line of code, the tuple on the right-hand side will be mapped into a value tuple with the fields using the types defined. Changing this from var will behave slightly different. If you explore the fields available on the local variable, you can see that the compiler no longer inferred the names. To introduce names for each of the fields, you can explicitly define that. This means that the tuple of the right-hand side is now assigned to the tuple as defined on the left. There's a reason that both of these alternatives are supported. We'll look at a good use case of this when we introduce a tuple as a return type. For now, let's continue to talk about the different types of tuple assignment and how the tuple can be deconstructed. What's really great about tuples is that it supports different ways of assignments. If we completely remove the name of the tuple, this will still compile. But what exactly does this mean? Instead of the tuple being assigned into a local variable of type tuple with the fields that we've specified, it's now assigned to these three different variables. The order of the right-hand side and the left-hand side need to match. Otherwise, it wouldn't be able to assign the value from the tuple into the local variable. We can take this one step further and remove all the explicit types and have the compiler infer each of the types for us. Use the var keyword to do this. Since the compiler knows the type used in the tuple, it will be able to figure out what the types of the local variables should be. You can even take it one step further and only have one var keyword. This will create three local variables. The types will be inferred by the compiler, and the number of variables defined here need to match the tuple exactly. You can try to have a different number of variables on the left-hand side of this tuple assignment. Notice how the compiler tells you that you cannot deconstruct a tuple with two elements into three variables. What we are doing here is not only assigning the right-hand side to the left, but we are doing something called deconstruction. Tuples have built-in support for this, which is what makes it possible to assign it in the different ways that we've looked at. Since the tuple can be deconstructed into multiple different variables, could we deconstruct the tuple into already existing variables? If you pause the video and try this yourself, can you figure out how to do this? If you are ready, let's take a look at how the tuple can be deconstructed into already existing local variables. Let's say that the application already had a variable for the order number and the sum, but it doesn't have the line items local variable. First, remove the var keyword from the start. This will tell you which of the variables do not exist in the current context. We can point the first variable to the order number and the sum to the local variable. I don't want to manually add a local variable outside of this definition. Do you know what we can do? You can add the var keyword. This will introduce a local variable with the name. And when the tuple is deconstructed, it will add the first value into the order number, which is defined above. It will map the line items into a new local variable. And finally, it will set the sum that was defined above to the value from the tuple. This makes working with tuples extremely pleasant. It's really much more flexible than what you'd get with an anonymous type. The code generated by the compiler will be similar no matter if you deconstruct into an already existing variable or if you deconstruct into new variables. Remember, it's really important that the left-hand side and the right-hand side have matching number of elements. Otherwise, you'll get a compiler error. In some cases, when you retrieve a tuple, you may not care about one of the values, and you don't want to deconstruct that value into a local variable. This is where you can use what is known as a discard. You saw this with the lambda, and the same idea applies to tuples. You use the discard by adding an underscore, and this simply means that you don't care about this value. We could therefore specify that we want a tuple deconstructed into two local variables, order and sum, while completely ignoring the middle one, which is the line items. You can discard as many as you'd like. You could even discard all of the values, or simply discard the entire return value. This would work for any assignment and is useful in cases where you explicitly want to say that you don't care about using that return value. Using discards can reduce memory allocations. As you've seen by now, tuples as a first-class citizen in C# is really a powerful language feature. The options you have in terms of deconstructing a tuple makes it useful in many situations. You've probably gathered by now that if you have a way of defining what type exists in the tuple, you're not limited to use this only in the current method. Next, we'll be looking at returning tuples and accepting them as an input parameter to our method.